Hi everyone, in this video we're going to go through the third module of Datacamp's free Introduction to R course, Matrices. So in this third module, matrices, there are a few topics that it's going to hit. First, they're going to be talking about what is a matrix and why would we use a matrix. It's going to talk about how we name matrices, talk a little bit about how we can add columns and add rows to the matrices. So essentially we're building our data sets within the R program itself. And then we're going to do a little bit of basic arithmetic on the matrices to solve some data problems. Okay, so it says matrix is a collection of elements of the same data type, numeric, character, or logical, arranged into a fixed number of rows and columns. So we can think about a matrix similar in a way we can think about an Excel sheet where we have data structures in rows and data structures in columns. Similar to a vector, the same thing applies to a matrix, is that it has to be the same data type, or in other words, the same atomic data type. So they all have to be numeric data, they all have to be character data, or they all have to be some sort of logical data for it to work. In terms of mixing the data, when we get to data frames, is somewhat analogous to the relationship between vectors and lists, where vectors are all the same atomic data type, and then lists, we can mix and match data types. Same thing here, the matrix is one atomic data type, and data frames, which they're going to talk about in later modules, is mixing and matching data types. We can construct a matrix in R using the matrix function. So it says consider the following example. We have a matrix, we call in the matrix function, and there are three particular arguments that we're going to pass into the matrix function. The first argument is going to give us the vector itself. In this particular case, we don't have a named vector already previously developed, so we're just going to use the numbers 1 through 9. The second argument is going to tell us how we want to indicate the flow of the elements within the vector. So we can either do it by row or we can do it by column. In this case, they're giving us the example of by row, and then we attach to that some sort of Boolean, either true or false. And then lastly, the third argument is the n row. So it should tell us how many rows we want to develop within our matrix using the elements from the vector that we've put in. So here it's asking us to construct a matrix with 3 rows containing the numbers 1 through 9 filled row-wise. So essentially what they're asking us here is just to follow exactly what they did for the example. So what we'll do is we'll call in the matrix function. The first will be the vector itself, or the vector elements. So in this case, it wants us to use numbers 1 through 9. The second is that they're telling us they want it to fill it by row. So we're going to do by row equals true. And then the third argument we're going to pass in is the number of rows that we want to fill it. So here it's telling us 3 rows. So n row equals 3. And we'll run the code. And then we can tell here that in the results we have a matrix that's developed with 3 columns and 3 rows. And then we notice here that we have the numbers of the elements filled row-wise. So by row is true, meaning it's going to be 1, 2, 3, 4, 5, 6, instead of 1, 2, 3, 4, 5, 6. So that's where that second argument is going to come in. So we'll click Submit Answer. Okay, so now we want to get our hands dirty, and the example they're going to use here is gross income from the Star Wars franchise for various movies. So in the editor, they've already defined 3 vectors for us: New Hope, The Empire Strikes Back, and Return of the Jedi. And we notice here that there are 2 arguments in the concatenation function. It says that the first element indicates the US box office revenue, and the second element refers to the non-US box office revenue. What they're asking us to do here, we want to build a matrix from these vectors. So we're going to use the concatenate function here to do it, to combine 3 vectors into 1 vector, and we want to call the vector box office. So let's do that first. So here it's telling us that we have the 3 different vectors that they've already built for us, which are representative of the 3 movies, and then we have 2 arguments in each of these. So what they want us to do is create box office, and we want to concatenate the 3 vectors into another vector. So we'll use the concatenate function here, and we'll put in New Hope. The second vector is Empire Strikes Back, and the third vector is Return of the Jedi. Okay, so we've done that. Let's just run the code. All right, and so now we have that vector is created from the 3 other vectors. So now the second set of instructions is to construct a matrix with 3 rows, where each row represents a movie. Use the matrix function to do this. The first argument is the vector box office containing all the box office figures. The second argument we have to specify by row true, and then the third argument will be the n row equals 3. So in order to do that, we are going to name our new matrix Star Wars matrix. So the same way that we name vectors in the past, we can use that to name matrices. Only now we're going to call in the matrix function, and then we want to pass 3 arguments. So the first argument is the vector we're working with. So here we'll use box office. And then they want us once again to use by row true. And then we want to do n row is equal to 3. What I want to do right here is we've passed this argument, but before we do that, let's see what this actual Star Wars matrix looks like. Okay, so I'm going to run the whole thing. Oops, not by toe, by row. Okay, let's run it. Okay, and we notice here that we have 2 columns and we have 3 rows. So the 3 rows are just the 3 vectors: New Hope, Empire Strikes Back, Return of the Jedi, and in each of those is the representative information from each of the vectors. Let's hit submit. Okay, now it's telling us to name our matrix. So to remember what's stored in the Star Wars matrix, we'd like to add the names of the movies to the rows. Not only does this help you read the data, but it's also useful to select certain elements from the matrix. So similar to vectors, we can call in functions, the row names and the column names, to name the particular columns and rows within the matrix that we're building. It says we went ahead and prepared 2 vectors, so a region and a titles vector, and we'll need these vectors to name the columns and the rows of the Star Wars matrix. So it's asking us here to use column names to name the columns of the Star Wars matrix, and we're going to use the region vector to do that. So we notice here we have all of our vectors that we've used. We've concatenated them into the Star Wars matrix. But then if we run Star Wars matrix, let's run Star Wars matrix. Well, let me run this first here. We'll run the code, and then we'll call in Star Wars matrix to see what it looks like. We'll notice here that we have the information, but the columns are just labeled as 1 and 2, and the rows are labeled as 1, 2, and 3. So what they're asking us to do is that we want to label these by region and by titles. So the columns 1 and 2, what we could see here is that we want to use US and non-US. US would be representative of the first column, non-US would be representative of the second column, and then the titles, the first one would be representative of here, A New Hope. The second one would be The Empire Strikes Back, and then Return of the Jedi would be number 3. So what we have to do now is map these vectors with the concatenated character elements in them, and we need to map it to the columns and the rows of the matrix itself. In order to do that, we want to name the columns with the region. So I'm going to call in the column names function. And the matrix we're working on here is the Star Wars matrix. Gets. We'll call in the region vector. Okay. Let's run this one more time and just see what this looks like. Okay, and now we've run that into the console. So let's type out our matrix and see what we have so far. Okay, so we notice here that we have US and non-US, which is the region vector, has now been mapped to the columns. So now we want to do the same thing for the rows. So we'll call in the row names function. And the matrix that we're working on is the Star Wars matrix. Gets, and then we want to use the titles vector to map it. Okay. So let's run the whole thing. And now let's type out Star Wars matrix. Oh, okay, so it's asking to print out. I didn't see that. Let's just type it under here. Star Wars matrix. All right, so let's run the whole thing. And we should see that the titles are now named for the particular rows, and that's happened. All right, so we'll submit the answer. Okay. Okay, so now we're going to do some basic arithmetic in the matrix that we've just built. It says the single most important thing for a movie in order to become an instant legend is its worldwide box office figures. So to calculate the total box office revenue for the 3 Star Wars movies, we have to take the sum of the US revenue column and the non-US revenue column. So in order to do this, let's do the row sums. And we're going to pass in the Star Wars matrix to do that. Let's run the code. Okay, so now let's check the worldwide vector and see if we can get a result. Okay, so it's telling us that the total amount for A New Hope was 775 plus million, 538 plus million for Empire Strikes Back, and 475 plus million for Return of the Jedi. So we'll click Submit Answer and move on. All right, so in the previous exercise, we calculated the vector that contained the worldwide box office receipt for the movies. However, this vector is not part of the Star Wars matrix. So we can add columns or rows to the matrix, in this particular case using the cbind functions, which merges matrices or vectors together with the column. So in this particular case, what we're doing now is we're building even more into our matrix, and then we're adding a particular column to our matrix. So the sum of those two into our matrix. So we want to add worldwide vector as a new column to the Star Wars matrix. And in order to do this, it's a very simple operation. We use the cbind function. So in this particular case, we want to build essentially a new matrix, and we want to call it All Wars Matrix. And so within there, we're going to use the worldwide vector, and we're going to attach the worldwide vector to the previous existing Star Wars matrix. So in order to do that, we're going to use a cbind. And the 2 arguments that we're going to pass in are the matrix and the vector that we want to add. So Star Wars matrix, and we want to add worldwide vector. Okay, so let's run this. Okay, and then the last thing that we can do is we can just check All Wars matrix, and we'll just run the code. Okay, so we see that we have the older matrix that we're using, so the Star Wars matrix, and then we've added the worldwide vector to it. And so basically it's just the result of summing those 2 columns across. Okay, so similarly, just like we added the column, we can add a new row. And so we use the rbind function to do that. So in our workspace where all variables live, it's already been initialized and contains 2 matrices, the Star Wars matrix and the Star Wars 2 matrix. So we should say in using R, in particular, I like to use RStudio as an integrated development environment. There's a separate window that we would see, which is our workspace, which would show all of the vectors, all of the matrices, all of the data frames, lists, et cetera, that we've built within the script itself. And so we can keep track of them through the workspace. So they're telling us here that sort of on the back end, there's a workspace, and that they've put in these 2 Star Wars matrices. So let's just see what these Star Wars matrices look like. So let's call in Star Wars Matrix 1. And we see that we have those 3 movies again with the US and non-US. And let's call in Star Wars 2 Matrix. And we have another one. So a different set of 3 movies, The Phantom Menace, Attack of the Clones, and Revenge of the Sith. And once again, we have the same data, right? So we have the US and then the non-US revenue for both of those. And so we have those 2 matrices that are already in here. It also tells us that if we want to see what's actually in our workspace, we can use the ls function. So let's do the ls function, and it tells us that we have the 2 matrices in there. Okay, so now we want to use the rbind function to paste together Star Wars Matrix and Star Wars Matrix 2 in that particular order. And then we want to take those matrices, make one larger matrice, and we want to call it All Wars Matrix. So very easy to do. Let's do the row bind. And we're going to pass in the 2 arguments, each of the matrices, to do that. Separated by comma. Let's run it. Okay. And at this point, let's just type All Wars Matrix. And we see that we have all of the rows combined now into one matrix. Okay, so here it's going to teach us the function column sums. And it wants us to calculate the total revenue of the US and the non-US regions and assign it to a new vector, total revenue vector. So all we're going to do here is we're going to use the column sums function. And within there, we're going to use it on the new matrix that we just built, the All Wars Matrix. and it's asking us to print it out. All right, so we should see all of the columns summed. Okay, so the total US is 2226 and non-US is 2087. Okay, let's click submit answer. Okay, so here we're going to talk a little bit about subsetting within a matrix. So similar to vectors, we can use the square brackets to select one or multiple elements from the matrix. Similar to what happened in the vectors, if you remember, we used the vector name and then we used the brackets, and it was one dimensional. So all we had to do was select either one element or a range of elements within that one dimension. So there were a few ways that we did that. If it was just a single element, we would use the bracket with the single element. If it was multiple elements, we could use the concatenate function. Or if we wanted the range, we could use the two numbers, the beginning and the end of the range. Within the middle, we use the colon. And so it's similar here. Only the thing is now we have to think two-dimensionally because the matrix is now two-dimensional. We have rows and we have columns. So it's telling us here that we can take a look at a matrix and we can use the brackets and we could subset 1, 2, which indicates that that's the specific element at the first row in the second column. Additionally, we can use ranges to do that. So 1:3, 2:4 indicates that that's the data on the rows 1, 2, 3 and the columns 2, 3, 4. So what it's telling us here too is that we could be a little bit more parsimonious. If we want to select all elements of a row or a column, no number is needed before or after the comma respectively. So in this particular instance, we're looking at a matrix and we just subset comma 1. That indicates all of the elements of the first column, and then similarly 1 comma without anything selects all of the elements of the first row. So to get back to the example of the Star Wars, what it wants us to do is it wants us to select the non-US revenue for all movies. So that would be the entire second column of the all wars matrix. And we want to store that in a new vector, and we want to call that vector non-US all. So very easy to do. All we're going to do is we're going to take the matrix that we're working with. We want to use the brackets to subset, and we want to use all of the elements in the second row. So we'll just use a comma 2. And then we want to take the average of that. So in order to take the average, we'll call in the mean function, and then we'll pass through the vector that we're working on that we just built. So the non-US all. Okay. So let's run that and see what happens. All right, so the average is 347 million. Okay, now what it wants us to do is that we want to select the non-US revenue for the first 2 movies in the All Wars matrix. So same exact thing, only right now we have to think about the rows that we want, and we have to think about the columns that we want. So let's take the matrix and we want to subset with the bracket. So it's asking us here that we want to use the first 2 movies. So that would be the first 2 rows, so 1 and 2. And we want to do it for the non-US revenue, which would be the second column. So we'll use the second column here. And then we want to take the average of that. So same exact thing. We're going to call in the mean function, and we'll use the new vector that we just created called non-US sum. Let's run it all. And so we notice that 281 is the average for the first 2 movies of non-US. So let's submit the answer. Great. Okay, now we can do a little bit of arithmetic within the matrices. So similar to what we've learned with the vectors, the standard operators, addition, subtraction, division, multiplication, etc., work in an element-wise way on matrices in R. So example, 2 times a particular matrix will multiply each element in that matrix by 2. As an example, we're a newly hired analyst for Lucasfilms, and it's our job to find out how many visitors went to each movie in a geographical area. You already have the total revenue figures in the All Wars matrix, which we've developed, and we're going to assume that the price of 1 ticket is $5. Simply dividing the box office numbers by this ticket will give us the number of visitors. So what we want to do is we want to divide the matrix by 5, and that's going to take each element within that matrix and divide it all by 5, and then we want to assign that to a new vector called visitors. So we already have visitors, gets. Let's do All Wars matrix, and we're just going to simply divide it by 5, and then it says it wants to print out visitors to the console. So let's run the code, and I spelled it wrong. Let's print it out to the console, And so it gives us the matrix back, and it's divided everything by 5, and that's going to give us the amount of moviegoers for each movie, US, non-US. Okay, a little more arithmetic. So just like 2 times my matrix multiplied every element by 2, we can actually do some multiplication within the matrix itself. Okay, very basically we can do that. After looking at the result of the previous exercise, ticket prices went up over time, and he wants us to redo the analysis based on the prices that we can find in this particular matrix. So what it's asking us to do is we want to divide the all wars matrix that we've created by the new matrix that they've provided, which is ticket prices matrix, to get the estimated number of US and non-US visitors for the 6 movies, and then we want to assign it to the new vector visitors. So same thing, we could just take all of the information in the matrix itself and we can divide them. Before we do that, let's take a look at these matrices first. So let's call in the all wars matrix, see what that looks like. And then let's call in the new matrix. See what that looks like. Okay, so we have different ticket prices for each of those. So we're going to divide the 2, and then what it's essentially going to do is it's going to take each of the elements and divide them by themselves. So 461 will be divided by 5, 314 will be divided by 5, 290 will be divided by 6, etc., etc. So let's run this. And now we have the new vector created. And now let's call in the actual visitors. Okay, so we have all of those numbers divided. So now it's asking us select the entire first column representing the number of visitors in the US and store this selection as US visitors. So once again, that's a subset. So now what we want to do is we want to take the visitors and we want to subset it with everything in the first column. So we'll use a comma 1, and that'll indicate all the US. And we want to find the average of that now. So we'll use the mean function to do that. And we'll just take the mean function and we'll pass in the new US visitors vector. We'll run it all. So 75 is the average there. 75 million. So let's submit the answer. Okay. And the next thing that we're going to work on is factors. I hope you enjoyed the video and found it helpful. If you did, make sure to give us a big thumbs up and like the video. If you haven't done so already, be sure to subscribe to our channel by clicking the link above, and make sure to check out some of our other videos. We'll see you again soon.